You know that feeling, that little heart sink? You've pushed code late at night, feeling pretty good about it, and then weeks later, you find this report about a nasty security hole.
Yeah.
And it's in some library you barely even remember adding.
Oh, yeah. Happens all the time.
It's surprisingly common, isn't it? A risk we just sort of overlook.
Totally. I mean, modern apps, they aren't built from the ground up anymore. They lean heavily on all these third-party libraries, right? Pre-written code, doing specific jobs.
Speeds things up for sure.
It does, but each one is like another potential way into your system. Could have known vulnerabilities, could have hidden ones. Ignoring that, it's like building a house with great doors, but, well, forgetting to check the locks on any of them.
Right, right. So today we're going to shine a light on this. We're doing a deep dive into managing these dependency risks. Think of it as your guide to staying safer in the software world.
And we've got some really interesting source material to dig into.
We do. We've looked at an article focusing specifically on OWASP dependency check, another on building custom security tools with Python. There's a about safety page from a company big on supply chain security, a piece about automating cybersecurity tasks.
Also a rundown of key Python libraries for security folks, and even an intro to using Python in CI pipelines. Quite a mix.
Yeah, a good spread. Our mission here is really to give you practical tools and, strategies, your first line of defense.
And we'll definitely spend some time on OWASP dependency check. It's pretty foundational for just understanding what you're actually pulling into your projects.
Okay, let's jump in then. OWASP dependency check. Sounds important. Layman's terms, what is it?
Okay, imagine you've got a security guard for your software project. That's kind of what this is. It's an open source tool, and it meticulously checks all those third-party libraries you've brought in,
Uh-huh.
and it cross-references them against this huge, constantly updated list of known security vulnerabilities. The guard analogy, checking the bags of every library. It's pretty accurate.
So it's like an automated background check for all the borrowed code.
Precisely. And it's really versatile, too. It
Ah.
supports a lot of different languages. Full support for Java and .NET, which is great.
Right.
But it also has experimental analyzers for things like CocoaPods, Swift Package Manager, Python, PHP's Composer, Node.js, Ruby, quite a few.
So chances are, whatever you're building with, it might be able to help.
Yeah, there's a good chance.
And what's this digital guard actually looking for? What kind of trouble?
It's hunting for what are called common vulnerabilities and exposures, CVEs for short.
CVEs, right.
Think of them like public wanted posters for software bugs that have security issues. Each CVE entry tells you what the problem is, gives it a CVSS score to show how bad it is.
Okay.
And crucially, it lists the specific software versions affected. It uses something called Common Platform Enumeration, or CPE for that.
CPE, CVSS, still sounds a bit technical. What do those actually mean for me day to day?
Well, CPE helps pinpoint exactly which library version has the issue, so you're not panicking about a version that's actually fine.
Ah, okay. Avoids false alarms.
Exactly. And the CVSS score, that gives you a quick read on how urgent the fix is. A high score means, drop everything. Dependency check handles finding these matches in your project's dependencies, which can be a real pain to do manually.
Okay, so it knows the bad stuff and how to identify it. How does it actually find it in my project files? Does it read all my code?
It doesn't do a deep dive into your application code like a manual review would. But it's smart about collecting identifying info about the library files it finds. It uses these things called analyzers.
Analyzers.
Yeah. They gather what's called evidence, typically the vendor name, the product or library name, and the version number. So if it's looking at a Java JR file, for instance, the jar analyzer pulls info from its manifest file, maybe a pom.xml if it's a Maven project, even the package names inside, like little detectives gathering clues for each library.
Got it. Detectives gathering clues. So what happens with those clues?
Right, so this evidence vendor, product, version, gets compared against a huge internal database, dependency check keeps. This database is full of CPE entries, built from the National Vulnerability Database, the NVD.
The official list of CVEs.
Exactly. If dependency check finds a match between the evidence from your library and an entry in its database, it assigns an identifier to your library.
And that identifier points to the specific vulnerability.
You got it. Once a library has that identifier, another part, the NVD CV analyzer, steps in. It uses the identifier to look up the actual CVE details from a local database that dependency check maintains and keeps updated. Think of it like its own organized filing cabinet of known issues.
Okay.
And then finally, after all that digging, it spits out a report detailing everything it found using these customizable templates.
Wow, okay. It's definitely more than just a quick scan. It sounds like a proper investigation process.
It really is.
Yeah.
There are four main architectural bits working together. You've got the engine, which kind of orchestrates the whole thing, starts the scan. Then the analyzers, the core part doing the evidence gathering and initial identification.
Hmm.
Then matchers compare the evidence to the vulnerability database. And finally, the report generator puts it all together in a way you can actually read and use.
And this all happens in a specific order, I assume?
Yeah, there's a defined sequence, different analysis phases. It starts with setup, then collecting info on your dependencies, does some pre-analysis, then the key part, identifying dependencies using those CPEs.
Right.
Then it tries to clean things up, maybe filter out false positives, groups related findings together. And finally, it uses the NVD data to confirm the vulnerabilities and generates the report. Knowing those phases helps if you ever need to tweak how it runs.
Okay, dependency check. Sounds like a really solid base. But the article we looked at asks a fair question. Is it the only tool you need? Are there other ways to go, maybe with different advantages?
That's a really important point. Dependency check is great for known vulnerabilities in its database. But, the security world moves fast, so other tools offer maybe more proactive approaches, things that integrate deeper into your workflow.
Like what? SNEC was mentioned in one of the articles?
Yeah, SNAC. It takes a much more real-time proactive stance. Instead of just running scans now and then, it plugs right into your development workflow. It's constantly watching your code and dependencies as you work.
Continuously.
Yeah. And the really valuable bit, it doesn't just flag a problem, it often suggests fixes and can sometimes even apply them automatically. It's a big part of that whole shift left idea in security.
That sounds incredibly useful. Like, imagine you're pushing against a deadline and SNEC just handles patching a vulnerability for you automatically. Wow.
Exactly that scenario. You're coding, you commit something, and bam, SNAC flags a critical issue in a dependency.
Hmm.
Instead of you stopping, researching, figuring out the fix, SNAC can often just open a pull request with the updated secure package version.
That's the strength then. Instant feedback, automated fixes.
Definitely its strengths. The downside. Well, it has a free tier, which is good, but for the more advanced features, you're looking at a subscription.
Makes sense. Okay, what about GitHub Dependabot? Loads of people use GitHub. They've probably seen that.
Dependabot is, a fantastic option if you're already on GitHub. It integrates just seamlessly, constantly watching your dependencies for known issues, just like the others.
And when it finds something?
It automatically creates a pull request right there in your repository with the necessary changes to update to a secure version.
So it finds it and basically proposes the fix right where you manage your code. That sounds super convenient.
It is. Especially for larger projects with tons of dependencies. Dependabot just works away quietly in the background. An issue pops up, boom, there's a pull request with the fix. Super easy to stay updated.
Strengths are the GitHub integration and the auto PRs then.
For sure. The potential weakness. Some might find that scanning isn't always quite as deep or comprehensive as a dedicated tool like SNCC, or even dependency check in certain situations.
So, okay, we've got dependency check, SNCC, Dependabot. How do you choose? Sounds like there isn't one single best tool for everyone.
You're absolutely right. It really boils down to a few things. Budget's obviously one. Open source like Dependency Check and Dependabot. Great starting points, especially for smaller teams or individuals.
Right.
If you need more advanced stuff, maybe compliance reporting or deeper analysis, then a commercial tool like SNCC might be worth the investment. Then there's workflow integration. How well does it fit with how you already work? If you live in GitHub, Dependabot is kind of a no-brainer.
Makes sense.
And finally, what do you need? Do you need that continuous real-time monitoring and auto-patching? That's SNCC's sweet spot. Or are periodic scans and detailed reports, like Dependency Check provides, a better fit for your security process?
It all seems to come back to being proactive, yeah.
Yeah.
Catching things early, not scrambling after an exploit.
Exactly. Which leads us nicely into the bigger picture of how Python fits into all this.
Yeah.
Especially automating these kinds of security checks within our development pipelines.
Python just seems to be everywhere in cybersecurity now. What makes it so popular for security pros?
Well, it's got a few big advantages. Number one is definitely automation. So many routine security tasks, scanning systems, crunching through logs, launching vulnerability tests, they can all be scripted pretty easily with Python.
Takes the grunt work out.
Totally. Second, it's super versatile and cross-platform. Your Python scripts will run on Windows, Linux, Mac OS, which is essential because security teams deal with all sorts of different systems.
So it's the workhorse language for handling those repetitive security chores. The article on building your own Python security tools mentions some basics, right?
Yeah.
Stuff you need to know.
It did. Yeah, if you want to use Python for security, you definitely need a good handle on the programming fundamentals. Variables for storing data, conditional statements if this, then that's logic loops for repeating stuff, functions to keep your code organized.
Standard programming concepts.
Pretty much. And being comfortable working with text, strings, and lists is really key because so much security data comes in that form.
And one article really stressed working with files. Why is that so critical for security folks?
Because a massive amount of security information lives in log files. Simple text files, maybe CSV files,
Yeah.
recording everything that happens on a system or app.
Right.
So being able to open those files in Python, read the contents using things like .read, maybe write findings back out using .write, that's core stuff. And often you need to process that data, right? Make sense of it. Python's string tools like .split to break lines apart and .join to put them back together are invaluable for that kind of log parsing.
Okay, this all seems to tie directly into that idea of baking security right into the development pipeline, DevSecOps, right?
Precisely. DevSecOps. Instead of security being this separate thing you tack on at the end, you integrate it into every stage. Continuous integration, continuous delivery deployment, the CI/CD pipeline. And Python is like a key tool for automating lots of those security checks within the pipeline.
Why is automating this in the CI/CD pipeline with Python such a big deal? What are the benefits?
Oh, several big ones. Speed, first off. Automation is fast. Python security scripts run quickly, fit right into the pipeline, helps you release secure software faster.
Catches problems earlier, too.
Much earlier, yeah. When they're usually way easier and cheaper to fix. Plus, automation brings consistency. Same checks every time. Reduces human error.
Frees up the security team.
Big time. Takes repetitive tasks off their plate so they can focus on harder problems. And maybe the biggest thing, it helps build a culture where security is everyone's job, not just the security teams.
Okay, what are some actual examples? What security tasks can you automate in CI/CD using Python?
Loads. Security testing is a big one. You can use Python to kick off SaaS tools, static application security testing. They check your code for bugs without running it. Or DAS tools dynamic testing, which test your app while it's running. And connecting back to our earlier chat, SCA tools, software composition analysis, like OWASP dependency check. Python can automate running those scans against your third-party libraries.
So Python can orchestrate dependency check within the pipeline.
Absolutely. Python scripts can manage the whole flow. Start the scan, analyze the results, create reports, even enforce policies, like automatically fail the build if a critical vulnerability is found.
Wow, so Python could actually stop vulnerable code from getting released.
Exactly. And it goes beyond just code testing. You can automate vulnerability scanning for container images, for the infrastructure the pipeline runs on, compliance checks too, making sure code follows secure coding rules, infrastructure settings are right.
What about secrets, like passwords and API keys?
Yep, automation helps there too. Preventing developers from accidentally committing secrets. Python can integrate with tools like HashiCorp Vault to manage secrets securely. And this whole idea of policy as code, defining security rules in code that gets automatically enforced, Python's often central to that.
How does Python actually talk to CI/CD tools like Jenkins or GitLab CI?
It integrates really well. These CI/CD platforms let you define build steps, right? You can easily add steps that just run shell commands or execute Python scripts. So plugging in your security automation is pretty straightforward.
Okay.
Plus, many CI/CD tools and security tools have APIs. Python is brilliant for talking to APIs. You can write scripts to trigger builds, pull down test results, interact with scanners. Some platforms even have specific Python plugins or extensions to make it even easier.
So it's not just security testing. Python can automate setting up test environments, checking code quality, secure releases.
All sorts of things. It really shows how security can become just part of the normal development flow.
Now, that About Safety page we looked at adds another layer, doesn't it? Supply chain security. How does that fit in?
Yeah, supply chain security is huge now.
Yeah.
Because modern software isn't just about the libraries you directly choose. It's about the dependencies of those dependencies and so on down the line. It's this complex web.
Right, it goes deep.
And Safety, the company, they're pushing this prevention-first idea. What really jumped out was their claim about their vulnerability database. They say it detects significantly more vulnerabilities than the public ones, like 4 times more.
4 times, that's a lot.
It is. They say they use AI to analyze millions of package releases, code changes. It really highlights just how massive the potential risk surface is, and that maybe we need more advanced ways to look for issues.
So relying only on public CV lists might mean we're missing a big chunk of the picture.
That's the implication, yeah. It underscores that risk. Safety mentions some wording examples too, like that malicious Express Exprue NPM package or the cache-free package leaking card data.
Ouch! Real-world consequences.
What? Definitely. These show how vulnerabilities can creep in anywhere in that supply chain.
Yeah.
It really drives home that point about needing proactive security that maybe goes beyond just checking the known public vulnerability lists.
Okay, so thinking beyond the automated scanning tools, what else does the Python world offer to boost our security game?
That article on top Python libraries for security mentioned several powerful ones.
Absolutely. Python's library ecosystem is just packed with tools for security pros, well beyond vulnerability scanning. You've got Scapy, for example.
Scapy.
Yeah, it's amazing for working with network packets. You can build them, send them, sniff them, pull them apart. Really low-level stuff. It's invaluable for penetration testing, network analysis, even building custom intrusion detection. Gives you really fine-grained control.
Sounds like getting deep into the network traffic itself. Exactly. Then there's the cryptography library. Does what it says on the tin, basically. Provides really solid, well-vetted crypto functions. It follows this cryptography by default idea, making sure you use secure recommended algorithms for encrypting data, setting up secure connections authentication, your go-to for protecting data.
Okay, essential for anything sensitive. What about mapping out networks, finding weaknesses there?
For that, you'd look at libraries like PineMap or Python Nmap. They let you use the power of the Nmap scanner right from your Python scripts. So you can automate network discovery, port scanning, vulnerability checks, and do it at scale. Really efficient for network audits.
Automation and scale again. Seems like a recurring theme.
Absolutely critical in modern security. Another powerhouse library is Impacket. It gives you low-level implementations of network protocols like SMB, MSRPC, super useful for advanced pen testing, maybe developing custom exploits or network tools.
Getting quite advanced there.
It can be, yeah. For password security specifically, there's BRIPT, secure password hashing, verification, using strong standard algorithms, and one more, Scapy HTTPS. It extends Scapy so you can actually peek inside encrypted HTTPS traffic. Crucial since so much traffic is encrypted now.
Wow.
So yeah, mastering Python and getting familiar with libraries like these, it gives you a really powerful arsenal for proactive security, for finding and fixing a whole range of threats.
This has been really insightful, a proper deep dive into a super important area for anyone building software today. The big takeaway for me seems to be that security, especially around dependencies, isn't just a checkbox. It's got to be continuous.
Precisely. It's an ongoing effort. We started with OWASP dependency check, right, as that fundamental tool for just seeing the known vulnerabilities.
Yeah, the baseline.
Then we looked at things like SNCC and Dependabot, more integrated, more automated solutions that help catch things and even fix them earlier in the process.
Shifting left.
Exactly. And then we zoomed out to see how Python, with its automation power and all those amazing libraries, lets you build security into the entire development lifecycle, the CI/CD pipeline, making security proactive and efficient, not an afterthought.
So, as we wrap this up, what's the final thought, something for our listeners to chew on?
Well, thinking about how sophisticated supply chain attacks are getting and how much we all rely on third-party code, the question really is, how can we as individual developers, as organizations, really build a culture of constant vigilance and shared responsibility for the security of these digital building blocks we all use?
Good question.
It's not just about running a scan, it's about integrating security, thinking deeply into how we build software, always learning, always improving, and understanding that keeping our software secure, that's really a team effort.
So keep exploring the tools.
Definitely. Check out OWASP, Pinch, Dependabot, Safety, dig into those Python libraries we mentioned, and really think critically, how can you bring these practices, these tools, into your workflow to build stronger, more secure software?